I wanted to go over slide 20 and slide 22 because a lot of you really struggled on this. So I thought I'd give you an opportunity to see how they should be solved so that you understand this material a little bit better. So the first thing we're looking at is a scatter plot showing you how the percentage of the U.S. population is compared to the year since 1960, and the topic is smoking cigarettes. So they tell you that in 1960, about 45% of the U.S. population smoked cigarettes. The percentage of the U.S. population that smoked cigarettes over the years since 1960 is shown in the scatter plot. So first they want you to write an equation for this trend line. So as we've been practicing, we know that we're going to write it in the form of y equals mx plus b. All we have to find out is the slope and the y-intercept. The y-intercept is here where the line crosses the y-axis. It's halfway in between 40 and 50, so we're going to call it 45. And for our equation, it goes at the end where the y-intercept goes. Now we have to find the slope. We're going to find 2 points. Notice this does not go through the line. That is not a point we can use. If you look down here, you can see this point does go through the line. So those are the points I'm going to use, the y-intercept and the second point that I just identified. So if I don't know how to make these lines thicker. Oh, there it is. If I draw my slope triangle from here to here, now I can count rise over run. But first, look at your scale. Each unit is worth 10. See how it's counting 10, 20, 30, 40? Okay, so we're going to be counting by 10. So from here to here is 10, 20, and halfway is 25. So my numerator for rise over run, so it's rise over run, the rise we just counted is 25. For my run, you can see here it's counting by tens also. So now let's count the run. 10, 20, 30, 40. The denominator is 40. But we still have to simplify. I'm running out of colors. If I divide both numerator and denominator by 5, I can simplify this to 5/8. But one more thing. Do you see how the line is going down? That means the slope is negative. So our slope is negative 5/8. Yes, you have to simplify. We always simplify. So going back to our equation, we now have negative, let me make it a little bit bigger, negative 5/8 is the slope. And now we have our equation for the trend line, y equals negative 5/8 x plus 45. So now we have to look and see what does x represent in the equation. Well, to find that out, all we have to do is look at the axes. Let's look at the labels. This is labeled, the x-axis is labeled the number of years since 1960. So that means x represents, what am I doing? What am I doing? X represents the number of years, but not just the number of years, it's the number of years since 1960. What does the y represent? Well, again, if you look at your y-axis, look at the label, it tells you it's the percentage of the U.S. population. So we're going to write percent of the U.S. population. So that's just asking you what the x and the y represent. In the next 2 questions, they're asking you about the slope in context and the y-intercept in context. That is very different. So we know that the slope is negative 5/8. Well, in context, that's telling you that the percent of people that smoke decreases 5% every 8 years. So the percent of people who smoke, well, I don't know if I can write small enough. Percent of people who smoke decreases And do you see how I'm using the slope itself, negative 5/8, decreases, that's the negative sign, by 5% every 8 years. Remember, your slope is y over x, percent of population over the number of years, 5% per every 8 years. So it comes directly from your slope. The y-intercept, remember we identified that to be right here at 45. Well, what does that y-intercept represent in context? It represents that 45% of the population, that's your y-intercept, it means that there were 45% of the population that smoked in the year 1960. Because remember, your y-intercept is where x is 0. Well, on this graph, x is 0 at the year 1960. So when it says in context, they want you to use the actual numbers. They want you to use your actual slope, but explain it using your labels. They want you to use the actual y-intercept, but explain it in terms of where x is 0. What does that y mean? Here it means 45% of the population smoked in 1960. So now it gets a little harder. Now we're going to have to use our equation that we came up with at the very beginning to answer some questions. So let me rewrite that equation first. Let me make it a little bit bigger. And let me make my pen a little bit smaller. Y equals negative 5/8 x plus 45. So there's the equation. Remember, x is representing, in this case, x is representing the number of years, y is representing the percent. So here they're telling us the percent. We have to figure out the year. So the y is the percent, so this is where I'm going to put 5. So the 5 is where the y is because y represents the percent of the population. So that's where the 5 goes. And now I have to solve for x. So this is a simple two-step equation. I'm going to start by subtracting 45 from both sides, which gives me negative 40 is equal to negative 5/8 x. And then my next step is to divide by negative 5/8. Now remember, when we divide by a fraction, we do so by multiplying by the reciprocal. So I'm going to multiply both sides by negative 8/5. When that happens, I'm going to move it over here a little bit. On the right side of the equation, negative 5/8 and negative 8/5 cancel each other out. Meaning, when you multiply those together, it makes 1. So that's how we isolated our variable, right? Because 1x is the same as x. That's what our goal was. On the left side, when you multiply negative 8/5 times negative 40, the negatives cancel out, and you end up with 64. Now here's the tricky part for this problem. 64 doesn't really make sense, right? Because we're trying to figure out the year. Well, remember, where x is 0, that's the year 1960. So to figure out the year when we would expect there to be only 5% of the population smoking cigarettes, we have to add 64 to 1960, because it would be 64 years after the starting point for the graph, which was 1960. When we add those together, we get the year 2024. Now, let's look at this one. In the year 2016, about what percentage of the U.S. population would you expect to smoke cigarettes? Now, they're giving us the year. So we're still using the same equation, y equals negative 5/8 x plus 45. But this time, they're giving us the year. That's the x. But remember, this x on this graph starts at 1960. So I'm not going to plug in 2016. No. We're going to take 2016 and subtract 1960. Because the graph doesn't start at 0, it starts at 1960. Well, when you subtract 2016 minus 1960, you get the number 56. That's what I'm substituting, and we're going to solve for y. So first, let's multiply negative 5/8 times 56. Let me do that very quickly with my calculator. I get negative 35. So what I did with my calculator, I multiplied 56 times negative 5 and then divided by 8. And that's where I got negative 35. So my answer is the percent. It says what percent population? Well, all I have to do now is add negative 35 plus 45. And that gives me 10. And in the context of this problem, that's actually 10% because my y-axis, those are the percentage of the population. So for number 11, we expect in the year 2016 that only 10% of the population would be smoking. All right, let's look at the bottom. Totally different equation now. We're done with smoking. Now we're looking at a scatter plot. Here's my equation. And in this scatter plot that we don't see, it's based on the temperature can't talk. It's showing the temperature based on the altitude above sea level. The equation for the scatter plot's trend line is y equals negative 0.0035x plus 59. Y represents temperature in degrees Fahrenheit. X represents distance above sea level in feet. Use the equation to answer the questions below. Well, first they want to know what type of association would the scatter plot demonstrate. Well, because the slope is negative, that means the association is also negative. Why do I keep using the highlighter? My apologies. I'm trying to use black ink. There you go. So we would have a negative association because the slope is negative. If the slope were positive, it would be a positive association. If there were no association, we wouldn't even have a trend line because when there's no association, there's no line. All right, for number 13 and 14, again, we're going to use the equation that we were given, negative 0.0035x plus 59. Let me make this bigger. I'm all straining to see, and yet, literally technology at my fingertips. Okay, so this time, they're giving us the distance in feet. We need to know the temperature. Let me look back. Y represents the temperature, and X is the distance. So that means we're going to take the X and substitute it with 10,000 because X is distance above sea level. So we're going to take Y equals negative point, don't forget that decimal, my gosh, that would be disastrous, times 10,000 plus 59. So let's put that in the calculator. I wish you could see what I'm doing. I mean, you kind of can, but not really. I should have done that. Anyway, I could have done that in my head. Negative 35 plus 59. We get y equals 24. So remember, in the context of this problem, that 24 is a temperature, so your answer is technically 24 degrees. You could type out the word degrees, or you can just put 24 in that answer box, and that would give you the right answer. For number 14, predict the distance above sea level if the temperature is 35 degrees. Well, this time they're giving you the temperature. The temperature is 35 degrees. Well, according to the information, it says y represents temperature. So we're going to use the same equation, but now we're going to substitute for y. So my equation is negative, oh my gosh, y equals negative 0.0035 x plus, I don't remember, 59. So I'm substituting 35 for y because y represents the temperature. Two-step equation. I'm going to subtract 59 first. You get negative 24 is equal to negative 0.0035x. My second step, my last step here, is to divide both sides by negative 0.0035 on both sides, just like hands-on equations, right? And the reason I do this is because that will help me isolate the x. Any number divided by itself is 1, and 1 times x is x, and that's what we're looking for. That's how we isolate the variable. So now we have to divide negative 24 by negative 0.0035, and we get, well, the negatives canceled out, and then I have 6,857.1428. But notice my directions are asking me to round to the nearest tenths place. That's just one number after the decimal. So I have to look at the hundredths place. This 4 is really what determines how to round. Because that number is less than 5, that means I'm going to keep the 1. So my answer is 6,857 and 1/10. That's it for slide 20. Do you have any questions? If you do, there will be a place for you to put that on Edpuzzle. If you have more questions and you need more support, of course you are welcome to stay for either ELO on Thursday or flex time. Let's move on to slide 22. In this example, in part 2, we're looking at the manager of a fast food restaurant who collected data studying the relationship between the number of employees working registers and the amount of time customers had to wait in line to place their order. So they give us a trend line. Y equals negative 70x plus 300. Y is the amount of time in seconds. We talked about this in class. That's an important detail. It's time in seconds. X is the number of employees working on the registers. So first, remember when we're talking about the type of association, you have to look at the slope. And because this slope is negative, our association is also negative. That part's pretty easy. Explain your reasoning. The slope is negative, therefore it's a negative association. Number 7. Which best describes the meaning of the slope in the trend line? So the slope is negative 70, and we know they told us that the y is the amount of time in seconds, right? So let's think about that. Slope is always y over x. In this case, I know this refers to 7. I'm writing in the space for 6. Forgive me. Anyway, y is the wait time in seconds over x, which is the number of employees. We'll call them workers. So also, going back to number 6, it would also be negative because if you think about it, the more people that are working, the less weight the customers have. And because these are opposite, it's a negative association. But anyway, moving on to number 7. Our slope is negative 70 over 1, right? Negative 70 over 1. So that means the wait time goes down, negative. The wait time decreases by 70 seconds per every 1 employee. So let's see, it can't be A because that's additional 70 seconds. No. B, the customers waited 70 fewer seconds. That matches the negative for every additional employee. So every additional 1 employee, I'm guessing, right? I'm kind of liking B. Let's look at C. Customers waited an additional second for every 70 additional employees. First of all, that makes no sense at all. If you have 70 more employees, are the customers going to wait longer? No. And what store has 70 registers? Nowhere I know of. Not even Walmart. Choice D, customers waited 1 second fewer for every 70 additional employees. Well, if there's 70 more employees, I'm guessing the wait time's going to go down by more than 1 second. Don't you think? So it's not D. The only choice that made sense was B. Number 8. Maria went to the restaurant. She waited 90 seconds to place her order. Use the trend line to predict how many employees were working and round to the nearest whole number if necessary. So let's get our equation. Y equals negative 70x plus 300. And they gave us the wait time. Remember, the wait time is the Y, so I'm going to substitute for Y. The 90 seconds goes there. Now we just have to solve for X. So to do that, I'm going to subtract 300 from both sides. That gives me negative 210 is equal to negative 70x. And my last step is to divide both sides by negative 70 in order to isolate my variable. When I do that, the negatives cancel out, and 210 divided by 70 is exactly 3. So your answer is, let's see, Maria wants to use trend line, blah, 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 predict. So we can predict that Maria, because Maria waited 90 seconds to place her order, we can predict there were 3 employees working. See how handy these trend lines are? I tell you what. All right, let's check this one out. I know I'm going to use my trend lines. Let me get that ready. This is a tricky one. 9 was tricky. Kiara went to the restaurant. She waited 3.5 minutes. Oh, what? Remember, they're giving us, our equation is based on seconds, not minutes. So I know I'm going to have to convert that to seconds. Let me finish reading the problem. Use the trend line to predict how many employees were working. So we're going to substitute for Y again because Y represents the wait time. But I need to convert 3.5 minutes to seconds. Well, there's 60 seconds in 1 minute. So 3 minutes, 3 times 6 is 18. So 3 times 60 seconds is 180 seconds plus half of a minute. Well, half of a minute is 30 seconds. So 180 plus 30 is 210 seconds. I'm going to replace, or I'm going to substitute 210 for Y because Y represents the wait time, just like we talked about before. So again, I'm going to solve for X. I'm going to start by subtracting 300. That gives me negative 90 is equal to negative 70x. The 300s cancel out. My last step is to divide both sides by negative 70 so I can isolate the variable. The negatives cancel out. 90 divided by 70. Let's see, it is 1.2857. It's asking us to round to the nearest whole number. Well, this 2 is telling me to round to 1. So our answer is 1 employee because 1.2857 rounds to the whole number 1. Last, Ashton walked into the restaurant and 4 employees were working registers. Use the trend line equation to predict how long he will wait to place his order. So again, let's go back to our handy dandy trend line equation. This time, they're giving us the number of employees. We're trying to figure out the time. So that means we're substituting for X. So now it's Y equals negative 70 times 4 plus 300, because they're talking about 4 employees. Negative 70 times 4 is negative 280 plus 300. And when I add these together, I get Y equals 20. So that means that if there's 4 employees working, then his wait time is predictably going to be 20 seconds long. It's not 20 employees, right? Because Y represents the wait time. So the wait time would be 20 seconds. Okay, I hope that was helpful. I hope this makes it a little more clear. Good luck on your quiz.